In this video, we're going to extend on what we learned with line of best fit back in Unit 4 to take a look at what this looks like when we have data that fits a quadratic model for a curve of best fit. And just to refresh our memory, a curve of best fit or trend line is a line or a curve that best represents data on a scatter plot. So we have to have data that has two components, an independent variable and a dependent variable. And we would plot those all in a scatter plot and see what shape they make. Remember that this process is also called regression, and in the past we looked at it for linear patterns where the lines, the data was pretty much increasing or decreasing at the same rate. And when we created that line of best fit, the line passed through some of the points, or sometimes it didn't. You had some points that were above or below the line, and the same is going to be true here when we do the curve of best fit with our quadratic data. Basically, you could see something that looks like this, where we have a full parabola represented. Sometimes we're just going to have part of a parabola represented, so our data could be like this. Our data could be something like this, where it's half of a parabola, so it really depends on the data that we have. Remember that the most important thing to start off with is by checking the scatter plot so that we know which type of data we're looking at, because now we're going to have either linear or quadratic, and we want to make sure that we use the best model. So here are our steps that we're going to use when we use the graphing calculator, the handheld. And these steps are exactly the same as what we did before. We go to Stat and then we edit the list. We put our data in. L1 is going to be our independent or our X value. L2 is going to be our Y values. And then we still go back to Stat and then calculate. In the past, we'd done number 4, the linreg. But now we're going to take option 5, the quadreg, when it's a quadratic regression. And then we hit enter all the way through until we get to the answer that we need. So we're going to take a look at an example of this and see what this looks like. So here we have our data set, and we are going to start by entering that into the calculator. So I have my calculator here, it's already cleared. And again, we're going to go to Stat, and then we're going to take option 1, that edit. And in L1, I'm going to put my X values. So I have -4, then -3, -2, we've got -1, 0, and 1. I'm going to go ahead and pause the video and put my Y value since there's a bit of a lag. Alright, now we just want to go ahead and double check that we had all those pairs done correctly. So -4, -4.8, -3, -8.2, and so on. The first thing that we want to do is decide which type of model we want to use. So in order to do that, we're going to use the stat plot, which is right here above y equals. So I'm going to hit second, y equals, and I'm going to turn plot 1 on. So I'm going to hit enter here, and I'm going to hit enter again to turn it on, and then everything else is all set. So now I'm going to hit zoom 9, because that will take me to the statistics window. And if I look at this data here, I can see that I can't draw one line that's going to neatly model this data. Instead, we see that U shape for our parabola. So we're good to go ahead and use our quadratic regression. In order to do that, I'm going to go to Stat, and then we're going to go over to Calculate. And in the past, again, we used that linreg model, but now this was quadratic data, so we're going to hit option 5. Just double check our X is L1, our Y is L2. We hit our enters all the way down to calculate, and this pulls up our quadratic regression equation. And remember, we just substitute in the values for A, B, and C. We may have directions to round, so you just want to make sure that you follow those. But for right now, we want to figure out which equation models this data in our answer choices. So we're going to have 1 point about 1x squared, so that rules out C and D, and then plus 4.2x. That's good for both of these. And then at the end, we're going to have minus about 4.9. So our final answer here is going to be B. Then usually what you're going to be asked to do is to use your best fit equation to determine the value of the function for some x value, or to figure out which x value gives you a given y value. And we can just do this right on the calculator. So I'm going to take my equation, and I am going to type in 1.1. Then I'm going to substitute in this x value of 9 in parentheses. Remember, anytime we substitute, we use parentheses. Plus 4.2x, so 4.2 times 9. And then minus 4.9. So we end up with 122 for that value. We can also do this in Desmos, and it looks a little different. I prefer Desmos just because I think it's a little more straightforward, but it's up to you which method you use. If you were to take the SOL, you'd have the option to use either the handheld or the Desmos graphing calculator. So we're going to look at that as well. So our steps for Desmos are a little different, but we'll still get the same result. We first have to make a table, which we can do by either hitting the plus icon or typing the word table, and then we'll create this regression template to pull data out of that table. The most important thing here is that you note that we do not have an equal sign here. Instead, we have the tilde or the squiggly line. That is the button directly below the escape button on your keyboard. So we're going to take a look at that and see what this looks like. So here we have a scientist dropping an object from a height of 200 feet, recording the height of the object every half a second to see how that height is changing. So I'm going to open up Desmos here, and we're going to start by creating a table. So again, I can either tape the word table, or I can hit the plus sign and then select table, and that'll pull it in. And I'm just going to fill in my data. So we have 0.0 and 200. We have 0.5, 195. We have 1.0, 185, and we can fill in the rest of the data. Got 1.5, 165, 2, and our last one, 2.5, 100. Again, like anytime we do this, we want to make sure that we've got everything in correctly. So we just double check that. And then we always want to check the shape of this data. So if I hit this magnifying glass here, it'll zoom right to where the data is. And I can see that this could be linear, but a quadratic is going to be a better fit. So now I'm going to fill in my regression model. I'm going to do that in the entry line directly below the table. The first thing I'm going to type is Y1, because that's going to pull these Y values from my table. If I was dealing with multiple data sets, multiple tables, I could change these subscripts, but usually for now you're just going to keep it as a 1. Then instead of equals, I'm going to type the tilde sign. Again, that's directly below the escape button. And I'm going to write the standard form for a quadratic equation. So it's going to be ax, but instead of x, we want x1. So I just type the 1 and it drops it down. And notice how if I just leave this, it creates a line, because y equals a number times x is just a linear equation. But instead, we want this to be quadratic. So I'm going to raise that to the second power, and it turns it into this parabola. But we got to keep going. So we're going to have plus bx1 plus c. So I have this standard form of my quadratic, ax squared plus bx plus c. And now Desmos has filled in those three values just like we get from the TI calculator. So if I were to type my equation here, it would be y equals, and we will round. Do we have directions? No, so we're going to round to the nearest tenth. Negative 16.4 x squared plus 1.1x plus 199.6. And we'll see that overlaps pretty closely with what's there, and that's my regression equation. So again, we can widen this out. Go a little wider. There we go. So y equals negative 16.4x squared plus 1.1x plus 199.6. And now we have our question, based on the model, which best approximate the height at 3 seconds? So I can just substitute 3 into my equation, so negative 16.4 times 3 squared plus 1.1 times 3 plus 199.6. And the height at 3 seconds will be approximately 55.3 feet, which seems to make sense because we can see that our height is decreasing as time goes by, and we'll be at about that 55.3 foot mark.